Hello, Algebra 1, and welcome back. Today we are on day 2 of our radical extension unit. We are going to start with a review of what we did yesterday just to make sure that we're all on the same page, and then we will go on to some new types of multiplying radicals. But pretty much this whole first page here is just a review of what we did yesterday, and then we'll get to the new stuff on the back. And then at the end, I will tell you what problems we are cutting from your homework tonight, which is worksheet 2. Remember, you do need to also do your 5-question Canvas quiz as a check-in. You will receive credit for that. And then homework you should really submit today, but I will accept homework up until the day of our quiz, which is on Friday. So that's just kind of, how we would normally do checking homework. Ideally, you have it today and submit it, but if you submit it by Friday, you'll get credit for it. So, all right, let's go ahead and start by looking at some perfect squares. Some work with this. Remember, these are numbers that you should have memorized. Be careful, number 1 is a little sneaky. We do have that negative underneath the square root, so this is undefined, not negative 11. All right, let's practice our perfect squares here. You should have 9 over 7. Notice the root goes away because these are perfect squares. And then 5 and 7 we need to be especially careful about. What a lot of people want to put is a 5 root 10. No, no, no. 100 is just 10. This is 5 times 10 is 50. All right, so go ahead, give this one a try as well. And you should get a 3 times 7 is 21. Okay, that's your 2-minute recap on perfect squares. Let's come down to simplifying with variables. Okay, so essentially we have 3 options. If we have a number, we're either going to do a tree or we have a perfect square. Okay, so that's like normal. If we have an even exponent, that means we have half of those are the pairs, and so half will come out. And if you have an odd exponent, basically an odd is one more than an even, right? So you'll have one left inside. That's the one that doesn't have a buddy, and then half will come out. All right, so let's try that. We don't have a regular number. We do have an even exponent. Half will come out. Half of 10 is 5. X to the 8th, that's even. Half will come out. X to the 4th. Since there isn't an odd exponent, and we didn't do a factor tree, there's no radical. This is just it. All right, number 2 has one of everything. So number square root of 4, that's a perfect square, so that's just a 2. X to the 4th, even. Half will come out. 4 divided by 2 is 2. Y to the 9th is odd. All right, so with an odd, 1 is always left inside. So you will have 1 always left inside. Now you're down to 8 y's. Half will come out. So y to the 4th. Okay, we're going to skip number 3 for now. Let's make this a little more difficult. Now we're going to multiply these, and then we'll simplify. So you're going to use the same rules as multiplying radicals yesterday. Outside times the outside and inside times the inside. Notice your outsides are just 1s. So 1 times 1 is 1. Insides, we'll do this guy times this guy. So 20 times 4 is 80. When you do x squared times x to the 3rd, we add our exponents. So that's x to the 5th. Think about what we did when we were foiling. And then y times y to the 10th, that's a 1. That's y to the 11th. Okay, so that's your first step. Now we're going to go through what we did above. This is a number here. I'll move up. Oh, I'll move up so we can see our rules. 80 is a number. It's not a perfect square, so we'll do a tree. 8 times 10, 4 times 2, 2 times 2, 5 times 2. And you should see that we have a pair of 2's, circle, cross out, another pair of 2's, circle, cross out, and then we're going to underline the 5. Okay. 2 times 2 is 4 root 5, but I'm going to leave some space in my 4 root 5. See how I've left all this here for my letters, okay, or my variables. All right, x to the 5th and y to the 11th are both odd, so leave one inside of each. So I'm leaving an x and I'm leaving a y. And now these go down by 1. So that's a 4 and that's a 10. And now they're even, so we'll divide by 2. X squared comes out, y to the 5th comes out. Okay, and that would be your answer. This would be one of the trickier ones that you have on your quiz. So let's do 2 more like that, just to make sure that you got it. Start by multiplying your outside times your outside, and your inside times your inside. So that's just a 1 out front. Remember, you're adding your exponents. M to the 3rd times m to the 5th is m to the 8th. Y to the 10th times y to the 11th is y to the 21st. We don't have a regular number. We do have an even. So half will come out. 8 divided by 2 is 4. 4 come out. Y to the 21st, 21 is an odd. So 1 will automatically stay in. Now I'm down to 20. Half will come out. There you go. Okay, one more like this. Multiply first. Your regular numbers you are just multiplying. 2 times 16 is 32. Your exponents we add. All right, so 1, 1, that's x squared. Y to the 3rd, y squared makes y to the 5th. Our number we'll do a tree with. I'm going to do 16 times 2 because then I can do 4 and 4. And again, yeah, the 4s will break down, but they're also a pair right now. So I'm just going to do circle, cross out, underline, 4 root 2. And again, I'm leaving a space because I need room for my variables. X squared is an even. Divide by 2. Y to the 5th is an odd. So we leave 1 inside. Now you're down to 4. Divided by 2. Ta-da! All right, there's your variable review for today. Now let's do some multiplying review. Okay, outside times the outside, inside times the inside. 2 times 1 is 2. 4 times 20 is 80. Check your root 80. That can break down. And we already did root 80, I think above. Actually, yeah, the problem like right above this. So I still have 2 pairs of 2's. And a 5 gets underlined, but be careful. This is not just 4 root 5, right? I know 2 times 2 is 4, but you still have this 2 in front. That's something to really be careful about. Make sure you actually get that number in front. 2 times 4 is 8 root 5. All right, great. Let's try another one. Outside times the outside. Negative 20. Root 27 times 3 is 81. Ooh. All right, now look at this. What is it that I want you to notice? If you said perfect square, you were right. Root 81 is a perfect square. This is just like the problems we did above, 5 and 7. Okay, do not do a tree. We should know that root 81 is just 9, and then we can multiply these. Notice there is no root because 81 is a perfect square. All right, one more like these, and then we will get to the new stuff, which is not hard at all. It's just an application of what we're doing right now. Okay, so once again, outside times the outside. And feel free, like if you feel like, oh, I got this, feel free to, go ahead and do the problem and then check to make sure that you're right. Okay, obviously don't go too far ahead, but if you want to pause the video and try it yourself, that's fine. Like that's one of the benefits of a video lesson is that you can kind of, work it how you need to. All right, 54 is not a perfect square, so I'm going to go ahead and do a tree. And I have a pair of 3s, circle, cross out. My 3 and 2 have nobody. It's very sad. They're getting underlined. 2 underlines get multiplied and go under the root. My 3, which is circled, will come out. Do not forget this 8. So your final answer should be a 24 root 6. Cool. Okay, so check out the back. Multiplying a square root by itself. This is going to be really important for geometry next year. So this is actually pretty easy. If you look, we're going to start out with these numbers here, and then we'll move to ones with variables. So when you do root 2 times root 2, what you were just taught is to multiply the insides and get root 4, right? But root 4 is a perfect square. Root 4 is just 2. Root 3 times root 3, well, 3 times 3 is 9, so this is root 9. But again, you should recognize your perfect squares. Square root of 9 is 3. Okay. Root 8 times root 8. Well, 8 times 8 is 64. Square root of 64. But what is that? It's a perfect square. What's your answer? 8. Okay, you should be noticing a pattern here. Okay, so when we do root 10 times root 10, some of you are already saying, well, I don't need to do all this. Yeah, 10 times 10, that's root 100, but what is root 100? It's just 10. So before we do these variables, what happens when you multiply a root by itself? Well, really, we don't need to do this step. Look, 2, 2, 3, 3, 8, 8, 100, 10, 10. That is always going to happen. So when you multiply a root by itself, the root goes away. And what was under the root is your answer. That means it can be like the most complicated problem in the world. It could be like square root of 1,000,002 times square root of 1,000,002. And the roots are just going to go away, and your answer is just 1,000,002. So square root of xy times square root of xy is just xy. And square root of a squared b times square root of a squared b is just a squared b. All right, whenever we multiply a root by itself, the root just goes away. That's it. That's all you have to know. So we're going to use that to do these 6 problems. We're squaring different types of radicals. So if you notice, every single one of these has an exponent of 2. But the difference is sometimes we have parentheses around the whole thing, and sometimes the parentheses are just around a specific part. Now, if you remember when we did FOIL, when you had something like this, and you had this squared, we duplicated it, right? Squared says, oh, write it twice. And then we would FOIL. Well, we're going to do the same thing here, okay? Except we're not foiling because there's no addition or subtraction. But when you see the squared, you're going to write it twice. Okay, notice the parentheses are on the whole thing, so I wrote the whole thing twice. And now we can use what we learned with multiplying to answer this. We're going to do the outside times the outside is 4. And you're going to do the inside times the inside is root 36. But again, root 36 is just 6. So 4 times 6 is 24. Now, if you're really good at this, we can use what we did up here. And that's what I would work towards, okay? What I would ideally like to see you do is to skip this step and instead say this. 2 times 2 is 4 times root 6 times root 6. It's a root times itself, so it's just 6. and get 24. Essentially, you can skip this step, okay? If you're getting the wrong answer, go through the whole process, okay? But if you can remember a root times itself is just the number underneath, you don't have to worry about this middle step here. Okay, so let's try it again. The squared is around everything, so I'm going to write the whole thing twice. -2 times -2 is +4. Root 6 times root 6 is root 36, or just 6. So this is a 24 as well. Okay. Now this one is different. You'll see the squared is only with the root 6. So what that means is you're only putting the 2 once, and then you have root 6 times root 6. Okay, so see how there aren't 2 2's? There's only 1 2. So bring down your 2 times root 6 times root 6 is just 6. 2 times 6 is 12. And again, the reason I know that is because of what we learned up here. The root goes away, and what was under the root is your answer. That's when you multiply a root by itself. Okay, 3 more. Squared is only with the root 6, so the root 6 is what I write twice. Root 6 times root 6 is just 6. -2 times 6 is -12. All right, so let's try it with some different numbers. See how the squared is around the whole thing? That means we're going to write the whole thing twice. 4 root 10 times 4 root 10. This one will be the same, but with a -4 root 10 times a -4 root 10. Outside, 4 times 4 is 16 times, you can either say root 10 times root 10 is root 100, but then you're going to have to simplify. Root 100 is 10, 16 times 10 is 160, or we can just skip that step and say root 10 times root 10 is just 10. 16 times 10 is 160. Last one. -4 times -4 is 16. Root 10 times root 10 is just 10. 16 times 10 is 160. Ta-da! All right, so let's talk homework. Find your worksheet 2. And here, I'm going to tell you what you're going to cut today instead of what you're going to do. So worksheet 2, you can cut 4 through 6. You're going to do the rest of this page. You're going to cut 21, 22, 23, 26, 28, and 29. Okay, so you're going to cut those problems. You are going to do your Canvas quiz and submit that. That is absolutely due today. I would do that next. Okay, do that right now. Then you can work on homework. You can submit your homework, ideally today. And then remember, there are discussion boards to ask questions on. And then also I'm making these videos ahead of time so I don't have to be rushed. But right now I'm working on how to do a video chat so that we could answer questions like we would in class and have it be live. So at this point, when you're watching this video, I've probably already figured that out, and I will have gotten you information on how to do that. So follow those directions for how to see a live session of answering homework questions, and go get your Canvas quiz done. Have a great rest of your day. Bye.